All right, guys. So just a quick reminder before we go over these review problems, there are a ton of videos that are already on the help video section. So if you're someone that feels like you're struggling with material, please go to that help video section and you can do elimination. There's videos on substitution. There's videos on how to graph. I don't think there's videos on how to graph full systems of equations, but there's videos on how to graph lines. So here's a system of equation. And again, please go to those help video sections because this one's going to be a kind of a quick one just for a quick practice. Now, and actually one more thing before we start, there are word problems that if you go to our schedule, it tells you specific word problems to make sure you know how to do and work through. And that's on our weekly schedule on our homepage. So what I'd like you to do right now is basically we're going to do all three methods for the same problem. Okay. So you could actually right now pause. And if you go ahead and try to graph this system of equation, you can go ahead and try to use elimination, and then you could try to do substitution. And then I'm going to go just show you the answer. So go ahead and pause it, try it, and then you can check to see if you're right. So I'm going to start off by doing the graphing one first. Now remember to graph equations. Now I don't have graph paper. You'll have graph paper on the test, I promise. I don't have graph paper right now, which is easier to kind of show you the concept this way. So in order to graph it, I need to solve both of them for y. So to solve this one for y, I would have to subtract 3x on both sides, which would get me 4y equals negative 3x plus 8. And then I'm going to have to divide both things by 4, both sides by 4. And when you divide both sides by 4, you would just leave this as negative 3 over 4 because you don't want to make it 0.75 x, and you get 8 divided by 4, which is 2. The other equation, if I do the same thing, I subtract 3x on both sides. That gets me negative 4y because it's minus 4y. Negative 3x plus 8. I divide both sides by negative 4, and you're left with it's a negative divided by a negative, which is a positive 3/4 x. And then here you get negative 2. Now we talked about in class that if they have different slopes, they're gonna intersect at some point. So this is definitely not going to be a no solution or an infinite solutions, because one of the slopes is 3/4, the other slope is negative 3/4. So on a graph, I would first, to graph this one, I would plot the y-intercept of positive 2, which would be up 2. And then I would use the slope. Negative 3/4 means down 3 to the right 4. So I go down 3 to the right 4. And then you would go ahead, and I would actually keep making your dots. And instead of going down 3 to the right 4, you could also go up and to the left 4. Up 3 to left 4. That's still negative because you have up is positive, 4 is negative, it would be to the left. Okay, and then you'd have a line, and I got to put arrows on the end because it goes on forever. And then the other one, I start at negative 2. That should probably be about there because it says minus 2. That's the y-intercept, 0, negative 2. And then it's positive 3, positive 4. So I go up 3 to the right 4. Up 3 to the right 4. Up 3 to the right 4. And eventually, I got to be honest with you, I haven't done, actually, yes, I do know where it intersects. It intersects like right here, okay? And if you were doing this on a piece of graph paper, this point right here would actually be at, hold on a second, it would be at, I think it would be at 2.5. Yeah, I think it's at 2.5 comma 0. I think is where you would go. Now you might say, Mr. Cass, how do we know it was 2.5? So this would not be one that we'd have you graph because you would have to kind of eye it. Now, I'm not positive it goes at 2.50, so I'm also going to solve this using elimination substitution. We'll find out the exact answer that way. But that's how you would graph it. Now, how would you do this problem using elimination? Well, the cool thing is I already noticed that I have opposites already. So if I have opposites already, I'm just going to add both equations. Now, please remember, if they weren't opposites, you could multiply one of the equations by whatever you want, and the other one by whatever you want. And remember, there is a video on elimination, a bigger video on elimination that is on our help video section. Okay, and you're going to have to use elimination. But because they're opposites, I add them, and I get 6x, 3x plus 3x. This eliminates 8 plus 8 is 16. I divide both sides by 6, and 6 goes into 16 twice, with a remainder of, because you get 12, 6 goes into 16, 6 goes into 16 twice, and you get a 12, you get a remainder of 4, 4, 6. So actually it wasn't 2.5. It actually was x is 2 and 4/6. You could also reduce that to 2 2/3. And I actually rather you write this as an improper fraction so that it'll help you solve the other one better. When you do 3 times 2 plus 2, you get 8/3. So 2 2/3 and 8/3, same answer. 16/6. It's all the same. Now, once you get that x is 8/3, I'm going to plug it back in one of the equations. So I'm going to plug it in the top equation. You could have plugged in the bottom one too. So 3 times 8/3, because it says 3x. So I'm just going to do 3 times x. You end up getting 24 divided by 3, which is 8. So this part is just 8 plus 4y equals 8. I subtract 8 on both sides. You get 4y equals 0. And if I divide both sides by 4, you get y equals 0. So our answer to this problem is x equals 8/3, y equals 0. Now, if I was doing the same problem using substitution, remember, all you have to do is you have to take one of the equations and you have to solve it for a variable. Now, this one's a little bit annoying, but I'm going to go ahead. Since we already did it, I already know that you can solve it for y. If you wanted to solve it for x, you could, but I'm going to make the bottom equation say y equals. And when you make this one say y equals, you end up getting, if I remember correctly, you end up getting positive 3/4 x plus, nope, minus 2. Let me just double check that. Yep, that's what you get if you solve this equation for y. Now, in the other equation, all we're going to do is substitute that in. So 3x plus, but not 4y anymore. We're going to put this in for y. 3/4 x minus 2 equals 8. And now I have an equation where there is only an x in there. So I'm going to just solve this equation for x. So I distribute the 4. You end up getting 4 times 3/4 ends up being 3x minus 4 times 2 is 8. I'm going to bring down my 3x and my plus sign. Equals 8. 3x plus 3x is 6x minus 8 equals 8. I add 8 on both sides, and you're going to notice that you get the same answer we got at elimination. X equals 16 divided by 6, or 8/3. And then you solve the other one the same way we did elimination. You plug it back into one of the equations. Okay, so that's just a quick practice, a review really quickly of all the different ones. Please remember what happens when you graph, when you get parallel lines. That would be a no solution. If they intersect, that's one solution. You actually have to name that solution. And if they're the same line, remember it's infinite solutions. And when you're solving it using substitution and elimination, please remember that when you're solving it, if the answer really was no solution, which it isn't, but if it was, you would end up with the x's and the y's canceling out, and you'd end up with like 0 equals 6, which isn't true. If it's not true, it means there's no solution. It can't be true. Okay. Now I know that was quick, but please remember, there's so many more videos on our help video section. Go look at them. All right. And make sure you do and submit the test before Sunday night. Thanks, guys.